Hello class, welcome to Unit 2, Lesson 2. Today we're going to go ahead and look at parallel and perpendicular lines. Your learning target is that you'll be able to graph the line and write the equation of a line given a point on the line and the equation of the parallel and perpendicular lines. Some notation that you guys might remember for geometry. The symbol for parallel looks like this, so two like lines straight up and down, and then perpendicular looks like that, because perpendicular, they meet at a 90-degree angle. Okay. So example 1, we're going to graph y equals negative 3x plus 1 and y equals negative 3x minus 5. The first one I'm going to do in blue. So the way we graph this is we go to our y-intercept, which is 1, plot 1, and then we graph our slope. Our slope is negative 3. So it's really negative 3 over 1. So remember, slope is rise over run. Okay, so we're going to rise negative 3, so go down 3, and then to the right 1. The other option is you can think about it as 3 over negative 1. So that means you go up 3 to the left 1. Okay, so, oops. And I want you guys to take the dots all the way, or at least when you draw your lines, or your arrows and your lines, make sure it goes all the way through that. That's not very straight, but there we go. There's my first line. There's a bit better. Okay, there's the first one. Now the next one. We're going to go ahead and graph y equals negative 3x minus 5. So I plot negative 5, my y-intercept, my b. So I go down to negative 5. Then I do negative 3. So we go down 3 to the right 1 or up 3 to the left 1. And then we would go ahead and draw that line. The graph forms what type of lines? How do you know by looking at the graph? I would say they look like they're parallel. Visually, to know if something is parallel, it is that they will never touch. They'll go on in both directions forever and they'll never touch. Your symbol to show parallel on parallel lines is it has these little arrows that's saying that they're going to continue on and that they won't touch. What must occur in the equation for the lines to be these types of lines? So if I look at my two equations I'm given, what do they have in common? I would say their slopes are the same. So they have same slopes. That's got to be true to be parallel. And they have different y-intercepts. Okay, that's what makes parallel lines. If they had the same slopes and the same y-intercept, they'd be the same line. Okay. Example 2, we're going to go ahead and graph these two. So I'm going to graph the first one, has a y-intercept of 4. And then my slope is negative 1 over 2. So I'm going to go down 1 to the right 2. The other option is I could go up 1 to the left 2. And then I'm going to draw my line. Make sure you draw all the way across on your sheet or on the graph that you're given. Okay, so there's the first one graphed. Now I'm going to go ahead and graph the other one. Let's do it in a different color. Let's do it in green. So we got negative 6 as my y-intercept. And then my slope is really 2 over 1. So I'm going to go up 2 over 1. The other one is do the opposite. Down 2 to the left 1. Down 2 to the left 1. And then I will go ahead and connect those. The graph forms what type of lines? In this case, these are perpendicular. The reason I know they're perpendicular, they are meeting at a 90-degree angle. And I can tell, like I said, by looking at the graph, remember our symbol for perpendicular. It's kind of that upside down T. And then what must occur in the equation of the lines for the graphs to be these types of lines? Okay, well, my slopes this time, I got negative 1/2 and 2. The slopes need to be opposite reciprocals. Okay, so what does the opposite part mean? It means positive and negative. So one's got to be positive and one's got to be negative. And then reciprocal, that's when you do the flip. Okay, so if I take this negative, make it positive, and flip it, I get positive 2. Here's another quick example. If I have a slope of -3, the perpendicular slope would be, this is currently -3/1. It's negative, make it positive, and then I flip it, it'd be 1/3. Those two would be perpendicular slopes. On our next slide, we have some slope facts. Parallel lines have the same slope. Parallel lines are two lines in the same plane that do not intersect. And then just some examples. We got our good old example with our slopes being the same, and since our slopes are the same and our y-intercepts are different, they are parallel. Okay. Perpendicular lines have opposite reciprocal slopes. Perpendicular lines are two lines that intersect and form right angles. Okay, so if I look at this slope here and this slope here, this one's positive, this one's negative, so it's the opposite, and then the reciprocal part, they're flipped. So that's how I know they are perpendicular. Example 3, or problem 3. We gotta talk about horizontal and vertical lines and how they are perpendicular. Y = 4. To graph y = 4, this is my x-axis and this is my y-axis. I want to graph where y is always 4. So I got 1, 2, 3, 4. Y is always 4 along this line. Okay, so here is my graph, y = 4. They are always horizontal lines. Then I have my graph x = 2. So that's where x is always equal to the number 2. So here's where x is 2, and it's always that up and down. If I have a vertical and a horizontal line, they are always perpendicular. They will meet at a right angle. Okay. It is important that you guys know how to graph these, and sometimes it's easier to, when you are asked about horizontal and vertical lines, to actually sketch pictures. Okay. So maybe just to recap, this one's our good old horizontal, and x = 2 is our vertical. Example 3 says find the equation of the line through the point 3,8 and is parallel to the x-axis. Okay, so I would plot my point 3,8. Here is 3,8. And I want it to be parallel to my x-axis. So here's my x-axis and here's my y-axis. So I want to be parallel to this line, so that means I'm never going to touch it, so I have to run this way. And then I ask you, is this an x equals or a y equals equation that I have here? If you're not sure, you could plot another point. I'm going to go here. This would be the point 5, 8. If you look at your two ordered pairs, you will notice that your y values are both the same. So this is the equation y = 8. So that is the equation of the line that is parallel to x. Example 4 says find the equation of the line through 3, 5 and is parallel to x plus 2y = 6. So what I need to know is I know what point I have. I need to know my slope, because in order to find the equation of a line, we always need a point and our slope. And right now we have our point. We need to find our slope. So the way we find our slope is we put this equation into slope-intercept form. So I'm going to rewrite. I got x plus 2y = 6. I would subtract x, so 2y equals -x plus 6, and then I would divide everybody by 2. Okay, so my equation is y equals -x over 2 plus 3. Now what I need from here is my slope. My slope is my number always right in front of my x. So what's in front of my x? It's really -1 over 2. So I can rewrite this. It's really -1/2 x plus 3. So this is my slope. Okay. Then step 2, or our last step, is to use the given point and slope to find the parallel line. And we all know parallel lines have the same slope, so I'm going to use the same slope. So I'm going to use m equals -1/2, and then I use 3, 5. So point slope form. We got y minus our y value. So y minus 5 equals our slope, negative 1/2. X minus our x value, which is 3. We have y minus 5 equals negative 1/2 x plus 3/2. And then I would go ahead and add 5 to the other side. So y equals negative 1/2 x. And then if you don't know, I would just use your calculator, 3/2 plus 5, or you can do it in your head, but if you don't know, feel free to use your calculator. 3 divided by 2 plus 5, and then we use our pal math frac, because I want it as a fraction. We get 13/2. Okay. So plus 13/2, and then that would be our equation of our line. Example 5, we're switching it up. We're going to go through the point -2, -4, and be perpendicular to 2x minus 4y minus 1. So same idea, we need to find our slope. The way we find our slope is we convert this into y equals mx plus b form. So the way I do that is I'm going to add the 4y to the other side. So I have 2x minus y equals 2x minus 1 equals 4y. And then to get y by itself, we divide everybody by 4. So 2/4 is 1/2 x minus 1/4 equals y. And I know it's written a little funny, so if you need to, you can reorder it. We'd have 1/2 x minus 1/4. And my slope of this line, it's the number in front of my x, is 1/2. However, I'm going to do perpendicular. So what is my perpendicular slope? It's currently positive, slope here, so it'd be negative, and then to flip it, I would get 2. Okay, so there is that. And now step 2 is to take my new slope and my point and plug it into point slope form. So I have y minus a -2 equals -2, my slope. Then I have x minus my x value, so plus 2. So y plus 4 equals -2x minus 4. I would subtract 4 to the other side to get y by itself, and so y equals -2x minus 8. And that is my problem, or sorry, my answer for example 5. Example 6. Graph the line with the slope of 1/3 and passes through -6, -4. So what I would do is go ahead, plot my point first, -6, -4. And from this point, I would go ahead and do my slope. Okay, so my slope is up 1/3, up 1/3. So there's the graph of my line. And I could go ahead and use point slope form to come up with the equation for this line. However, if I have the graph, I'm going to go ahead and find my y-intercept right off of it, which is right here. And so my y-intercept is -2, so b equals -2. So if you notice that, you can just take your slope, 1/3, and then your y-intercept, and write y equals 1/3 x minus 2. The other option is, you don't maybe notice that right away, you go ahead, plug your slope and your point into point slope form. So we have y minus a y value, 4, equals my slope, parentheses x minus the x value, which is 6. We distribute our 1/3. 1/3 times 6 is 2, and then I would subtract 4, so y equals 1/3 x minus 2. And they match up. So either way you can do it, it will work. Example 7. Find the slope and y-intercept of the line and draw its graph. Okay, so what I'm going to do is, to find my slope and y-intercept, slope-intercept form would probably be the easiest, so I'm going to get y by itself. So a few ways you can do this. I'm going to subtract 4 and add y. So add y to both sides and subtract 4. So I have y equals 2x minus 4. Then tells me I'm supposed to say what the slope is and the y-intercept. My slope, it's always a number in front of the x. You guys remember, don't write the x with it. My slope is 2, and my y-intercept is -4. And then we're going to graph it. So using my slope and my y-intercept, I plot it, so I go to my y-intercept and -4, and then I go ahead and graph my slope, up 2/1. And there is my line. So there is example 7. Your homework is bookwork, page 120 or PDF 149. Numbers 25 through 36, 41 through 52. This assignment is due the next time I see you. If you need graph paper, you can feel free to use graph paper on Notability if you don't have graph paper. Otherwise, you can just do your best to sketch it on your own. If you have questions, feel free to message me. Have a good day.